So hold on to that. And, oh yeah, put that in your.
That's another question from our school.
I have handed you guys the lesson for today. You should put it in your notebook. All right. I would put it after session 2 rather than before it, right? Unless you read backwards, unless you read right to left in your notebooks, but yeah. All right, so we're going to get into this right here. And first, it's dealing with math today. And we're going to be talking about rules of divisibility first, okay? These are some things that we should know, but some of it is review. Some of it might be just to reinforce what we do know. So. Can someone tell me the rule for determining whether something is divisible by 2? Okay?
As long as it's positive.
Positive? So negative 6 is not divisible by 2.
Oh yeah, that's right.
Wait, was it 2?
So 8 is not divisible by 2. Ends with an even number. So it has to be an even number.
Yeah,
0, no. Okay, so it's even, okay?
But 6 is even, isn't it? Yeah.
Yeah, but you said negative. You said negative.
Even.
Yeah, that's why I said negative 6.
I'm not even.
Is 558 divisible? Yes. Matthew? Okay, you're here. Grab a seat. Yeah, and did your mom give you something to give me? Is your mom here?
No, my mom's gonna pick me up.
Okay. All right. Well, just take a seat and just get started. Do I need to remind you guys that we start at 9? Okay. So, is 558 divisible by 2?
I can wake up at 8:30 to get snacks.
Yes, it is. Okay. You guys should have a pencil. Start writing. Okay. So number 3. How do we know if something is divisible by 3? Odd numbers? 7. Is 7 divisible by 3?
No. What the heck?
Is 7 divisible by 3? No, so that rule doesn't work. What is the rule for 3?
I have an idea.
You have an idea?
Oh no, never mind, because I was gonna say anything with that ends in 3, 6, 9, but 15 is divisible by 3. So that's
12.
Yeah.
12 is divisible, but it's not 3, 6, or 9. Okay? Who knows the rule for 3? Who knows? Of course it is. If it's divisible by 3, it is a multiple of 3. How about anyone here know the rule for 3? The rule for 3 is you add up the digits, and the digits represent a number that is divisible by 3. So in this case, I'm going to show it to you. It's going to be 5 plus 5 plus 8. That's 18. Is 18 divisible?
Yes.
So it is. So this is a yes. So the rule is it's a sum of digits. So if the sum of digits is divisible by 3. So that's our rule there. If the sum of digits is divisible by 3. Who knows the rule for 4? Was that Akiko? Did you have it?
I don't know that.
What's that? Well, 2 is even. Is that divisible by 4?
Oh no.
Jack?
Well, they have to be even, but they also have to be something else.
Something else. So something else. So that's right. Something else for 4. Okay. I would say that's like, what's that?
Multiple of 4.
Of course, it is a multiple of 4. Okay, the rule for 4 is the last 2 digits are divisible by 4. So when you're looking at this, you're asking yourself, is 58 divisible by 4? What do you guys think?
Yeah, no.
It's not, because if you look at it, 56 is divisible by 4, and 60 is divisible by 4, but 58 is not. You have a remainder there. So this is a no. So the last 2 digits are divisible. Okay, what's the rule for 5? Anybody know the rule for 5 here? Okay. Yes.
Yes, the number ends with a 5 or a 0.
Ends with a 5 or 0. Okay, that's correct. So this is obviously 558 is a no, right? Not divisible by 5. Okay. Who knows the rule for 6? Anybody know the rule for 6? The rule for 6 is that a number is divisible by both 2 and 3. It's not an either or. Either or means, oh, it's divisible by 3, so it must be 6. But it is not that. It is 2 and 3. Okay. So 2 and 3. So 558, yes or no? Do we need to do any calculation here? We shouldn't. So yes or no, Zoe?
Yeah.
It's a yes. Okay. There's not a simple rule with 7, so that's why 7's not on the list. 8 doesn't have a universal one either. But for 9, who knows the rule for 9? Jack?
Wait. I think I know because I know that 9 times a number is that number. Like, yeah, never mind.
Okay. Anybody else? We're not looking for what 9 times, right? We're looking for, if you just looked at a number like 558, can you tell if it's divisible by 9? It actually has a rule that's very similar to the 2. And the rule is that you add the digits, and the sum of the digits is divisible by 9. So this one, again, is 5 plus 5 plus 8. We know this is 18. Is that divisible by 9?
Yeah.
Yeah, that is. So this is a yes. So this is the sum of digits.
I do 10.
Let's hear Jason. What's the rule for 10? It's the hard one, man. This is the one that you may have to sit there and calculate for a while. Are you kidding me? Someone help out Jason here, besides Jack, who we've heard from. Catherine? Ends with a 0. Okay. You need your coffee. Okay.
You already had this coffee though.
Okay. Ends with a 0. This is obviously a no. Okay. So you guys should have written all this down. I feel like this is kind of new for a lot of us here. It seems like a lot of these rules were not like things that you guys actively knew off the top of your head. I'm going to tell you right now that these rules will help you on a lot of math problems, because what's going to happen is you're going to be asked a question such as, like, which of the following is not a factor of 558, right? And then you're going to have to choose it very quickly. You could sit there and crank it out, or you could quickly do it. One of the cool things about all even numbers is all even numbers follow the same suit as 2. They all can only go into even numbers, okay? Because even times even is even times odd is still even, right? So this rule of 2 actually applies to all the evens, but the other evens have additional types of rules, such as 4, 10, and 6, okay? Any questions on that? Let's move forward then. So we'll turn this page here, and instead of dealing with page 19, I want to look at 20 for a second. That's on your right, okay? And I want to talk about definitions for a second, okay? Who here can tell me the definition of integer? Jack, what's an integer?
A number.
Any old number. Like,
Yeah.
so 3.5.
Well, it has to be a whole number.
Wait, you said a number, right?
Yeah, a whole number.
Has to be a whole number. -4.
That still works.
Still works. Technically, the definition of whole number only includes from 0 to infinity, positives. But we're going to say whole number meaning non-fraction, okay? So an integer is a non-fraction. That's the easiest way to think of it. because it includes everything from negative infinity all the way to positive infinity, as long as it's a whole number, meaning non-fraction, no decimals, no fractions, okay? All the whole numbers from negative infinity to positive, like so 1 is an integer, 0 is an integer, 1 billion is an integer, but 1 billion.5 is not, okay? 2.5 is not, 1/2 is not, negative 3/4 is not, okay? So no fractions, no decimals, okay? You guys might be wondering, wow, why is Eli making such a big deal about these definitions? The reason is because they'll throw a question at you really quickly and they'll be talking about these words, yet they slip it in really casually. And so if you don't know what it is, you're kind of like, I'll just choose any number, like 3.5. And that's not going to work, right? So you've got to use the numbers that work, okay? For the next one here, on this one, let's hear from Mia. What would you say is the definition of digit? Oh, I should have asked that one first, actually. Digit. That's the first one. On page 20. You should be writing definitions on page 20. Who knows the definition of digit here? Let's hear new voices here. Okay, go ahead.
The place
Yes, that is, they are places, but that's not the definition of digit. Okay, that would be a phone number. Okay, who else wants to? So digits are specifically a single number from 0 to 9. A lot of people forget about 0 and they think of just 1 to 9. But when you see a math problem that talks about digits, it's saying that it's a number from 0 to 9. So that's what we want to deal with there. On the next one here, let's see what's the next one here. Let's hear from Sydney. What's the next one on our list besides integer? Positive and negative. Tell us what positive and negative are.
positive is number. Any number above 0.
Any number above 0. Greater than 0. Yeah, so less than 0. Okay, greater than, less than. Okay, that's pretty easy, right? Let's go with Akiko. What's the next one here? Consecutive numbers here? Okay, what's the definition of consecutive? Anybody want to chime in on consecutives here? Donna.
Number after.
One number after another? Okay, let me put a list up here. And you guys tell me if it's consecutive or not. Just a second. Can I put in this? Is this consecutive? 1, 2, 4, 6, 8, 9. Is that consecutive?
No.
It's not. Why is this not consecutive? I saw a resounding no. I heard a resounding no. Why is that not consecutive?
It doesn't have.
Yeah, it's inconsistent is what happens, because this is plus 1, plus 2, plus 1, plus 2, right?
It's plus 2. It's plus 1, plus 2, plus 2.
Wait, oh, plus 2,
No,
plus
it's
2.
plus 1.
Oh, you're right. That is plus 2. Plus
I
2.
know, but 1 and 2.
And then plus 1. That's inconsistent. Thank you for catching that. It's very inconsistent. You guys can see that, right? Yeah, Jack?
There's something you can consecutive going backwards, like 10, 9, 8, 7, 6, 5.
You mean decreasing?
Yeah.
Yeah, decreasing, yes. So if it was 10, 9, 8, yeah, those are consecutive. They're just decreasing numbers. So yeah, if you had 8, 9, 10, that is consecutive. So our rule for consecutive is numbers increasing or decreasing by a consistent pattern, okay? So that also means you could have consecutive even or consecutive odd. So you could have 1, 3, 5. That would be deemed consecutive. Or if you had 78, 80, and 82, those are even consecutive numbers, okay? Consecutive numbers don't have to start at 1, okay? That's what I want to drive home. They just need to follow a consistent pattern of increasing or decreasing, okay? So we should write these definitions in here because it's really important to know. Any questions on that? We're good? Okay. The next one, Victor. Yeah, they're asking about multiples and factors. What is a multiple first? Okay. Who wants to help out? What is a multiple? Let's hear other voices here. Give me your name again.
Matthew.
Matthew? Do you know what a multiple is?
Multiplies
Not exactly. Jack?
A number that's divisible by the number it's a multiple of, so, yeah.
That's like, it is what it is. That's what it sounds like.
Well, no, it's like divisible by a number, or it's like pretty much something times itself.
Not exactly something times itself.
I don't know how to explain it.
I'm going to make it easy, okay? A multiple is the product, also known as the answer, when you multiply two factors, okay? So it's the product of two factors. Okay? And what is a factor? Who? What is a factor? Some of you guys are like, I don't really know the difference. Who cares? Okay? That's what it seems like. Okay, a factor is basically a number that is multiplied by another factor to produce a multiple or an answer. Okay? Now, some of you guys are like, wow, that's a lot of concepts and terminology. Can you make it real? Yeah, let's make it real. Let's put something in here. Okay, so I wrote 2 times 3 equals 6 here. Which one is which here? Someone want to tell me? Catherine? Right. This is correct. For some of us, where that section there that says, how do we distinguish between these two? This is the easiest way to distinguish. Rather than memorizing terminology and definitions here, think of factors as parts, okay? Think of the multiple as a result, okay? So this is how you should remember this. I want you guys to write this down in the part that says, how can we tell the difference between a multiple and a factor? I want you to write 2 times 3 is 6, factor times factor equals multiple, part times part equals result, okay? This is really important because a lot of these math problems, they throw around the language very freely, and they expect you to know the difference. A lot of students, when the question is dealing with factors, they start thinking of multiples, results. Right? A lot of times when a question deals with multiples, a lot of students think of parts. That's not the one. We need to know the difference. That's like someone saying, okay, that's like someone saying, actually, that's not a really good example, but I'm trying to think of something that fits it. But like something, a San Franciscan and an East Bay person, they're both Bay Area people. But a Bay Area person is not necessarily a San Franciscan. Does that make sense? Part times part equals result. That's the easiest way. I don't want to give you too weird of a comparison. I just thought of that off the top of my head. But do you guys see that there? Okay. Okay, and at the bottom of this page, we're dealing with remainders. Who wants to tell me what a remainder is? Delaney.
Oh, so a remainder is like from the value, so
leftover number, right? That doesn't divide evenly. Okay. Something else that I wanted to mention that's on the bottom of this page is PEMDAS. We should know this. We're actively using this, right? Yeah. You can call it brackets. I actually met this one other tutor who, when she's from England, she has this funny English accent. She says, "Oh, you guys call it PEMDAS," and I'm mixing up my accent, but she goes, "We call it BODMAS." I'm like, "What's BODMAS?" And I was like, she goes, "Brackets, operations, division, multiplication, addition, and subtraction." Okay, she's got the very, I think it's called the Cockney accent or something. It's really funny when I heard it. BODMAS. Anyways, sounds funny. It does? Okay, I'll make it Indian. In India, we do the BODMAS. It is the BODMAS. Okay. There you go. All right, so anyways, I know. So let's continue here. We know what PEMDAS, this order of operations matters because for a long time when we're doing arithmetic, we do everything left to right, and we simply do that. But when you do PEMDAS, you do it, no, you do it according to parentheses, regardless if it's on the left, the right, or the middle. You do your parentheses first, you do your exponent second, regardless of where it's located, okay? That's the point of PEMDAS, okay? So let's go back to page 19, which is on your left. You don't need to flip anything, but let's just do these one by one. How about this? Let's do it quick fire. I want you guys to work on it silently for 2 minutes, and I'll go over it with you for a second, okay? All right, let's get back into this. I know that for some of you guys, this is a little challenging. Delaney, do me a favor, close that door right there. Thank you. So, what is the tens digit of this number here? Let's ask, let's hear from Sydney. It's 4, okay, and then arrange these in order, Mia. Yes, okay, and what about 8? Did you put 8 last? Okay, I didn't hear you there on that one. Okay, okay, Cindy, number 3. Remainder is, okay, 32 is 5, okay, and then next one, Catherine, next one. 861, correct. Next one, Donna. 16, correct. And then Victor, number 9, or number 6. 69, correct. And then number 7, Zoe. You can get there? Matt, is Matthew?
Yeah.
Okay, number 7.
13.
He said, Matthew said 13, 51, 59, and 119.
51 is
51 is not prime. Tell us why, Jack.
just divisible by 3.
It is divisible by 3. If you added the digits 5 plus 1, 6 is divisible by 3, so it is divisible by 3.
What the other 3 are.
119 is the trick. 119 is not prime. Some of you guys probably thought 119 was prime. Let's look at it for a second. First of all, let's use the rules that we talked about just a few minutes ago. The first thing we say to ourselves is this an even number? Obviously, it's not even. So all your even numbers are out. Just like that. Okay? Then add up the digits. 1 plus 1 plus 9. So that's going to be 11. Is 11 divisible by 3? No. Is 11 divisible by 9?
No.
Does it end with a 0 or 5?
No.
So when all of these are exhausted, some of you guys are like, it must be prime, right? This is not a prime test. This is just, are these numbers divisible by these? This doesn't tell you, is it prime or not prime, okay? 7. 7, I said, is a unique number. So 7, you're just going to have to test it out. And if you did this and divided by 7, you'll find out that this goes in there 17 times. So 7 times 17 equals 119. So 119 was not one of the primes. The primes there were just 13 and 59, okay? So this divisibility test helps us just to determine if a number is divisible by these individual numbers. It does not guarantee that it's prime. You're going to have to test out 7. If you exhaust everything else, test out 7, okay? 11 is easy to do though, Jack, because it's usually the double number. Okay, let's continue with the next one, number 8. Delaney, did you get that one? Okay. Akiko, did you get 8?
I'm doing
You're doing it right now. Okay, let's go back for a second. Delaney, did you get 9? We'll come back to 8 in a second. What did you get for number 9 there?
that's correct.
38 is correct. Okay. Akiko, did you get 10? Okay, let's go over here, Jason. 10? It's 75:45. Now let's talk about number 8 together for a second. Jack, you want to talk about 8?
Yeah.
Okay.
Well, I got 7 because it said that P to S is 20, and then it said Q to S is 11. So that meant that P to Q had to be 9. And if Q to S is 11, then P to R is minus 9, since P to Q is 9. And then that's how I got my answer for Q to R.
So you found out PQ was 9. That's correct.
Yeah.
What he did was he subtracted QS from the total, which is 20. And then did you subtract the 16 from the 20? Is that how you did it? Or did you take the 9 away from the 16? what you do?
No, well, it said that P to R was 16, so I just subtracted 9.
9 from 16. That's how you got 7. That's all you needed to do. That's perfect. Excellent. So that's all you did. You're using different parts to find the final answer, which is that.
I think I did something different, but that works too.
So if the total is 20, you subtracted 16 and got 9. I mean, subtracted 11, sorry, and you got 9. So 9, 11 equals 20. Then you took this 9 away from the 16, and that's how you got 7 now. So that's pretty common on this test, okay? They're going to have those things. How many of you guys got 100% on this thing? Not exactly? Okay. All right, let's continue to the next page. Let's talk about basic operations here. And this is a very straightforward question here, and it's asking which of the following is equal to 16. Let's go with Sydney. You want to read this one and tell us how you would do this one. So you're going to have to calculate here. So go ahead and lead us through this. You want to calculate instead of just read it? Go ahead and do that. Yeah, that might be the best way to do it. Okay, what'd you get, Sydney? Which, yeah, tell us each of the answers for A through E that you calculated. Go ahead and tell us. A was 4, okay. E 16, okay, that's correct. And then you didn't calculate anymore? You didn't calculate anymore? You did? Tell us the other ones. C was 4. C was not, wait. C you said 4. Okay, yeah, that's right. Okay, next one. Okay. So none of those. So the answer is B here. So answer is B is 16. She followed PEMDAS, made it very convincing. The reason why I was glad that Sydney did all of them, some of you guys are like, I found it, I'm done, I'm not doing any more, okay? Is because if we don't calculate correctly, sometimes we'll get a number and it will be, 16 or something like that. But when we put in a different number, like if we're asked to plug in numbers with variables, 2 of the answer choices might give us the same answer. But if you put in a different number into it, you might find out that only one of them is going to give you the right one. So sometimes, especially when there's variables, you've got to plug it in more than once, okay? So that's how you got to do that. Let's look at an example, number 2 here. Let's go with Mia. You want to read this one for us? You're looking at page 22, number 2.
X is between 1 and 5. X is also between 3 and 8.
Okay. Okay, does anybody want to step in here? Donna? 4, tell us why 4. So the first statement tells us this, that X is between, 1 and 5. 1 and 1, that's impossible. Okay, between 1 and 5. So the only numbers that X is allowed to be here is 2, 3, and 4. The second statement, Jack, what does the second statement tell us?
So it's between 3 and 8, and so it has to be between 3 and 5, and the only number between 3 and 5 is 4.
4, 5, and 6. So this is the only common number between the 2 statements there. Do you guys see that? So 4 is our best answer here, okay? So that's what that is. Let's go to number 3 here. Catherine, you want to read that one for us? $33 divided by 7. Less than 33 divided by 7. And you said 3?
No, I just.
Is your answer?
No, I just.
Okay. Okay. So how do we determine that? What do we do with 33 sevens? Jack, what would you do too?
Well, I divide 33 by 7.
Okay, and what did you get?
4, and 5 7.
Right? Oops. 4 and 5 sevens, correct. So our answer should be,
4.
it should be 4, okay? Because 4 is the next number below 4 and 5 sevens. That should be pretty obvious right there. Okay, Cindy, you want to do number 4 for us? Yes, okay. Go ahead and try that. The first thing we do is the parentheses here, which is 5 times 2, right? 5 times 2 is the first thing we do here. So that's going to be 10. So we have the 5 times 2. Hey guys, little conversations. None of that right now, okay? 5 times 2 is obviously 10. Then you still have a parentheses, so 4 times that is going to be 40, right? So you have 60 minus 40 plus 12 is 32. 60 minus 40 is 20 plus 12 is 32. Follow PEMDAS. That's all you're doing right here, okay? Follow PEMDAS. Any questions on this? Okay, we will move forward then.
I have a question.
Yes.
Really?
Yeah, I'll have you guys turn in the homework from last week at the end of class or at the break probably, because people were just shuffling in and coming in, so I just didn't want people coming up here during that. So, yes, really. Huh? Yeah, just bring it next week. That's fine. We'll just do it next week. Oh, well, bring it the week after, because you're right, Jason.
I brought mine.
The next week is the 14th because STA has a retreat and some people are taking the SSAT on the 14th. We will not have class. Okay.
I'm now taking the SSAT.
You are taking it next week?
No, yeah, sure, let's get the retreat.
No, I don't know if you can, but okay.
It's mandatory.
Let's continue, guys. Small talk later. Okay. So let's talk about positives and negatives on page 23 real quick. So this should be pretty easy here. Victor, read this one for us and tell us how you would do this. Yes. What would you do here? You'd subtract it and you would get -3, correct. Can you give us the rule for deciding whether or not something should be negative? Yes, Jason? Kind of, but not really. This is how I would generally say it. The easy way to think of it is, think of the absolute value of each of these numbers here. If 8 is -8 has a greater absolute value than 5 does. So when you're subtracting them, even though psychologically you're thinking, it's a 5 plus a -8, right? What am I doing with this? You're really subtracting like 8 minus 5, but then you're going to attach a negative symbol on there because what happens is this is -8. So because that was originally -8, it's going to be -3 as an answer. Okay? How many of you guys feel very confident with your negatives and positives? You guys are good at that? Okay,
Yeah.
good. All right, good. Okay. Let's go to number 6. Donna, you want to read that one for us?
5 minus -5. I mean 5. Yeah, 5 minus -5 minus 5.
Okay. What did you get on that one?
5.
It should be 5 because negative times negative becomes positive, so that becomes 5 plus 5. And because it's 5 plus 5, that's 10 minus 5 here. Jason, you want to do the next one? No. Okay, don't go ahead. All right. Jason, go ahead.
5 times negative 4 is negative 20 times negative 2, that's positive 40.
Right, so you went negative 20, negative 2, positive 40. Correct. Thank you for volunteering, Jason. We want to hear more. So, correct, 40 on that one. We should know the rules of positives and negatives. On the right column where all those remember notes are, they give us kind of an overview of that. And at the very bottom, you can see the multiplication rules of negative times or divided by negative is always going to be positive. Positive times or divided by negative is always going to be negative. So that's a good thing to do. Okay. How about number 8 here? Zoe, you want to do that one for us? That's correct. Negative 0.5 on that. So a lot of people get confused by this, but yeah, it's really negative 3 divided by 6. So this is negative 1/2. So yeah, this answer is negative 0.5. Okay. So a lot of people flip them thinking it goes the other way, but this is negative 3 divided by positive 6. Okay. Any questions? The best answer there was C. Okay. All right. Let's move forward a little bit here. Let's talk about factors, multiples, primes, and consecutive numbers. Okay. Matthew, can you read this question for us? So this question has a lot of terminology, right? More than just a few words here. Greatest, common, prime, factor. 4 different things here. So how should we find the greatest prime factor, common prime factor of these 2 numbers? Jack, what would you do?
Go from higher to lower.
Higher to lower? Okay, what would you do
Well,
here?
of the answers. Because if you go from the lowest to the highest, then
Okay.
it's like a waste of time because you can get one that's prime,
Okay.
but it's still not the highest, so you have to go from
I like what Jack is saying about back solving. You can do some back solving. So what would you do here?
I think it's 14, but actually no, it's not 14.
Is 14
No.
a prime number?
No, it's not. 7 and 2.
So 14 doesn't work, Catherine. So I heard you're Spanish, okay? So it's not 14.
7 is prime though.
The only primes here are 7 and 2.
Yeah.
So you can only choose between those 2 numbers, right? 7's your best answer here,
Yeah.
right? The greatest, meaning
I'm tripping.
the largest.
What if it's 7 divided by 5 and 2?
Well, they're not asking for division here. So real quick, if we didn't have these answer choices in front of us, where we could go through a process of elimination, how would we have found the greatest common prime of these 2? Who wants to tell me that? Jack, what would you do?
I think it would have to be less than 28. I'm not sure.
Yeah, so, okay, instead of just kind of fielding numbers out there like that, because you're like, well, is it 28 or is it 42? Why don't we break down these numbers? How would we break these down? Mia, what would you do? Yes, how would you do it? How many of you guys use the factor tree? The tree?
Oh, I know.
Jason, you wanted to tell us? Let's have Jason break it down. Which one do you want to break down? Who wants to do factor tree? Let's hear new voices. Donna? 7 and 4, 2 and 2. Okay. Do you want to do the other one? Okay, go ahead. 4 and 2. 7 and 6. So 2 and 3, or 3 and 2. Correct. So this obviously gives you the greatest common prime, right? So yes, Jack, what did you want to say?
I was gonna say that the answer also could be equal to either of the numbers given to you, because if it were, it would be impossible because the numbers given you can't be prime because you can't get,
You can't, yeah, they can't be broken down.
is it true that it has to be less than, the lower number, you know?
What do you mean less than the?
Like,
Well, between these two, yes.
Oh, they're down?
But
Yeah.
unless one of them was prime. So,
we could minimize it, this is 14,
Yeah.
7, and 2, and then, you know.
okay, good. Let me talk about this for a second. The reason why I'm going into this, even though we know the answer already, is this. Is doing the tree the only way to break down factors?
No.
The answer is no. So the answer is no. And in fact, I'm going to tell you guys the tree is only useful if you are looking for primes. I don't use the word only very often. The word only is a very strong word because it means 100% or it means 0%. Okay? It is only useful to find primes. Why do I say this? Because if I said, what are all of the factors of 42? How would you find it? Did we find all of the factors of 42 here?
No.
No, we didn't. So if we're looking at the factors of 42, you have 1 and 42, 2 and 21, 3 and, let's see, 3 and, no, it's 3 and 14, okay? 4, does 4 go in there? No, it doesn't. Does 5 go in there? No, it doesn't. Does 6 go in there? 6 and 7. This is how you know you're done, because there's nothing in between 6 and 7. You guys see that? So when you're looking for all factors, you don't do the tree, okay? I'm being very emphatic here, because some people do the tree every single time. The tree is not guaranteed to give you everything. Look at what our tree gave us for 42, just 7, 6, 2, 3. Look at the list. The list is 1 and 42, 2 and 21. That was not on the tree. 3 and 14. 14 was not on the tree, right? So the tree is only for primes. Write that down. Tree is only for primes. List gives you all factors, okay? Okay, good. So let's go to let's go to the bottom of this page. This is also very useful. It's saying 2 is the smallest prime number and the only even prime number. This is very important. One of the classic tricks on these tests is they'll talk about what are all the prime numbers, and a lot of people think that 1 is prime. How many of you guys think 1 is prime? 1 is not a prime number, okay? Negative numbers are not prime. 0 is not prime, okay? The smallest prime is 2. So I want you guys to write a note there. 1 is not prime. 1, 0, and negative numbers are not prime, okay? You need to carve that in your memory because that is a classic trick that they throw at us, okay? So every positive non-prime number greater than 1 can be represented as a product of a series of primes. This is kind of what Jack was saying. He's saying bigger numbers like 28 could not have been the answer because it's made up of prime numbers, right? So that's why that wasn't there. Yes, we're gonna have to. Hold on. When you look at tests, okay, they're really testing your knowledge of the vocabulary. So it's important to spend some time thinking about what these words mean, okay? Because after a while, math gets more and more complicated, and if you pop open a textbook and try to read it, you'd be like, what? Okay, because it gets really complicated, right? The one thing I want to tell you guys is that it's important to pop open the textbook and read it. Because when you're not in class and you don't have somebody to ask the questions to, the textbook has the answers, okay? Let's go to number 10 here. Jackie, you want to do this one?
I want to do 11.
Are you going to do 11? I'll come back to you. Let's have Cindy read 10 for us.
Multiple of 18 and 30.
Okay, how would you do this one? What is a multiple?
It's like It's like one factor.
Right? Factor times factor equals multiple. So what are we looking for? What is a multiple of 18?
Wait, what?
What is a multiple of 18? Jack, wait your turn. Don't shout out. Okay?
9,
Why?
because
Because Jack said it?
like, 18 times 5 is 19.
Correct.
30 times 3.
Yes. So that's a common multiple there. Okay, I don't want you guys to just do the math by feel. Okay, math is it works by order of, and method. Okay, what I want you guys to do is this. When you see the word multiple, what do you think? What is multiple? I see no reactions right now. I want reactions. What is multiple? Jack, what's a multiple? Without looking it up.
A product when you multiply two vectors.
So it's a result. Okay, I need to ingrain this in you. You're looking for a result. That means this. If the question said what are the multiples of 30 under 100, right? You shouldn't be thinking in reaction like, oh yeah, 60. 90. Okay, don't do that. Okay, that's what I see. Even though you guys physically are not doing that, but the way that you guys answer, you're giving me random numbers out of the blue. Okay, that's what I'm seeing. Because I know that Cindy, you heard Jack, but 90 is not the first number people think of when they think of multiples of 30. When you think of, or multiples of 18, if you're thinking multiples of 18, you're thinking of 18 times 1, which is 18. Then 36, then 54, then 72, then 90, okay? What I'm telling you guys here is that you have to think from least to greatest. It shouldn't be reactionary. If I said, what are the multiples of 18? I think 18 goes into 18, and then it goes into 36. Okay, that's what I'm seeing in you guys, okay? This is simple. It's just 18 times 1, 18 times 2, 18 times 3, 18 times 4. Okay, with this problem here, multiples of 30. Okay, 30, 60, 90. Okay, 30 times 1, 30 times 2, 30 times 3. This is easier to spot the answers that are equal, which is 90. Okay, so it's not reactionary. You guys see what I'm saying? Okay, let's go to number 11 now. So let's go to number 11. So let's have Catherine. Just wait. Catherine, go ahead. Hold on. So numbers that are divisible by 7, that are less than 45, how do we do this? So let's go with method, not reaction, because some people are like, 49! Wait, that's not less than 45. I can't use that. Okay, so we should not be reactionary. We should go with method. So let's look at numbers that are multiples of 7. What's the first one?
7.
7. Next one?
14.
Next?
21. 28. 25.
28.
28 and then 35.
35. Anything else?
42.
42. Which one here is prime? Okay. You guys see this? Jack, don't shout out answers anymore. Okay. Seriously, don't do that anymore. Okay. It really detracts from everyone else's learning when you shout out. Okay. So don't do that anymore. Seriously. 3 weeks now. Okay. So the answer is 7. It's the only prime number here. Okay. So 7 is the only prime in here. and it's the only one divisible by 7. Questions? Okay. Jack?
If a number is divisible by 7 and it's more than 7, then it's not prime, because the only number that's divisible by a number that's prime would have to be that number.
The
Or,
original
in this
number.
case.
Right, exactly that. You can go to the bathroom if you want.
I don't need to go back. I actually want to say that.
Okay. All right. I could tell you didn't. You just wanted attention. I could
No, I
tell.
want to say that.
So earlier. So, anyways, let's go to number 12 here. Let's hear from this side of the room. Donna, you want to read number 12 for us?
The largest of 7 consecutive whole numbers is 84. What is the average of the sum? 81.
81. How'd you get 81? You didn't even give me a chance to erase what I have up here, but how'd you get it?
So, consecutive and 84 is the highest one. You add 84 plus like 83 plus 82 plus 81 plus 80 plus 79 plus 78 plus, oh wait, that's 81. And then it equals 1267.
Wow. 5, 6, she added it up. 567 divided by 5. Is that what you did? It's not 567, is it? What number did you get again?
567 divided by 7.
Okay, it is. Okay, 567. And then you got, good. You could do that. Donna did it the long, hard way to do it, okay? Which was correct, but I'm going to tell you guys something that makes it easier. Because we didn't even have time to read the question. She worked ahead, obviously, I could tell, because there's no way she would have added that in her head while reading that. But what I will tell you is, for this question, it tells us that these numbers are consecutive, okay? And so if they're consecutive, we know that the mean and the median are equal to each other, okay? That makes it way faster, because we don't have to add everything up. We don't have to divide by 7. We just look at the mean and the median. This is 81 right here. And we know that's the median because there's 3 below it, 3 above it. So it is the mean and median. What I want you to, does everyone understand what I just said there? Sort of? Okay, median is a middle number. Median, here, if consecutive. Okay, the median equals the mean, all right? That's classic knowledge there, okay? The median equals the mean. How many of you guys are like, I don't see the difference if it wasn't consecutive? How many of you guys are like that? A little bit? Okay, so Kiko's kind of like, not totally sure. So let's talk about this for a second. If I gave you a list of numbers here, like this, 1, 2, and 3, okay? 1, 2, and 3 are consecutive, right? The mean and the median are 2, right? It's the same thing. But if I gave you 1, 2, and 3 billion, the median is still 2, but the mean is about 1 million and change. Do you guys see that? There's 1 million and some decimals. Do you guys see that? Because 3 billion, I mean not 1 million, 1 billion would be the mean, the median. The mean, I'm sorry, erase all that. The average will be 1 billion, okay? Because 3 billion divided by 3 is 1 billion, okay? And it doesn't matter with 1 and 2 here, okay? 1 and 2, they have no weight at all. 3 billion divided by 3 is 1 billion. You guys see that? So the mean and the median are not always the same thing. Median is still 2 here. Do you guys see that? Median is 2 here, median is 2, median is still 2 here, but the mean here is 2, the mean here is 1 billion. Do you guys see that? So that's the difference, okay? Okay, let's continue then on the next page. Actually, let's do this. There's a practice quiz. Let's take a quick break, 5 minutes, and then and we'll resume after that, okay? All right, so let's continue here. And if we don't get to doing this quiz later, it'll be homework. I just like to be generous. So let's talk about this. We're on page 29 now. Okay, so let's go to page 29. And on page 29, I want to talk about the collegible method for word problems. A lot of times you'll see word problems, there are no equations there, so it's a little bit harder. If they just gave you an equation, you just go ahead and calculate away right there, right? But when it's a word problem, we have to translate. And a lot of times we need to translate words into equations by parts, not by sentences. Because usually these are like 3 sentences long, and you read the whole thing, and you're like, whoa, what do I do with all this information? Okay? Step 1, translate words into numbers and math. Okay? That doesn't mean that every single sentence you translate automatically. What it means is you go sentence by sentence, because the first sentence might give you an equation, the second one might give you other variables that you need to translate, but they don't necessarily combine immediately. Okay? The second thing you do when you do that is translate names of people into variables, names of parts or things into variables. So if you had boys versus girls, you could just change it to B and G, right? If you had students, it could be S. If it was books, it could be B. But instead of just having a number, right, translate it into something, okay? Because that's how you form an equation. Determine what the question is asking for. Maybe it's asking for how these numbers interact with each other. Look for words that you're familiar with, like product, like difference, subtraction. They won't use something as obvious as subtraction. They'll say difference, or they'll say 3 times something, right? Or they'll say 3 times greater, right? So you're like, oh, 3 to 1, okay? So you have to look for that kind of language there. Determine what the question is asking for. Maybe it's looking for a ratio of boys to girls, or a ratio of boys to students, or something like that. That's a fraction, okay? So that's kind of what we have to look for. Use the given information to form an equation and solve the equation, okay? So let's go to number 1 here. And let's start with Akiko. You want to read that for us?
Of which are white. If exactly is stated of white self-equivalence and then how many self-equivalence are not included.
Okay, so you have 2 sentences here. And actually, you could start by just looking at the first sentence. The first sentence says, the clubhouse contains 24 soccer balls, 2/3 of which are white. How would we change that into variables first? Translate that. Who wants to translate? Jack?
B is the total amount of soccer balls, and then W.
And how many is that?
24.
Okay.
And W is B times 2/3, or 2/3 B.
Okay, so let's slow it down for a second. So you have that 24 times 2/3. How many white soccer balls do you have?
16.
So this is going to be 16. This is basically 24 divided by 3 is 8. 8 times 2 is 16. Okay? So we have 16 soccer balls. So if we have 16 soccer balls in total, this is white soccer balls, okay? We've translated the first sentence, and we've actually made these numbers make sense to us, okay? The second sentence tells us what to do with the white soccer balls. What do we do with this? Let's hear from Donna. What would you do here?
Subtract 8.
Subtract 8. Why do we subtract 8 here?
Because 8 of them are
8 of the white soccer balls are inflated, right? So this is 8. This is inflated, okay? And that gives you, 8 that are deflated or uninflated. So this is white soccer balls. Okay, correct. So our answer should be 8 here. Is it easier to work through it piece by piece? Would you guys say it's easier to do it that way rather than to read 2 sentences, try to do it all at once, right? So that's how I want you guys to do this. Mentally, you should be thinking of these questions. What information am I solving for? What information am I given? How can I use the given information to find the solution, right? That's what we're doing. We're breaking it down into pieces, okay? Any questions? The language of any word problem can be translated. So that's what we want to do. Let's go with number 2. This is a good question here. Cindy, you want to tell us how you would do number 2?
2 less than the sum of 3 and 7. You'll do like 3 plus 7 minus 2 is less than.
Okay, she said 3 plus 7, and then minus 2. And you got?
Oh, 8.
That's correct. I think what's really important is that Cindy knew that you're taking the 2 away from the sum. Okay? I'm going to write 2 sentences on the board, and I want to see if you guys see the difference here. What's the difference between these 2? Jason, what do you see as the difference?
Also, I think 2 less than 10 is like 2 subtract 10, and then 2 less than 10 is 10 subtract 2.
That's right. So these are different by just one word here, the word than, but the format changes it completely to 2 minus 10 versus 10 minus 2. Okay? So one word can make that big of a difference. Okay? Any questions on that? You guys are all cool with it? Okay, good. Let's continue. Let's go to number 3 here. Catherine, you want to read number 3?
Jody earns $60 per week. Carol earns 3 times as much as Jody per week. How much will Carol earn in 4 weeks?
What do we translate first here?
So Jody
Translate.
is oh.
Translate. Who wants to translate? Delaney?
Oh wait. So J equals.
That's what I want to hear. J equals 60. Okay. Next part. Delaney?
And then wait, Carol earns 3 times as much as Jody. So wait. 3C.
Is it 3C? Akiko?
Well, C equals 2.
C equals 3J. Okay. Some of you guys are like, wait, I'm not sure if I multiplied the 3 times J or the 3 times C. The way I would do it is this. In your head, or you can do it physically, you can say to yourself, this is Carol on your left hand. This is Jody on your right hand. And you can tell that Carol is more than Jody. So physically, you go like this. Oh, so that means I got to multiply Jody by 3 to make them equal to each other. That's how you do it. Okay? For some people, that really works. Okay? If you can't tell which is which. All right? So now that we have this, how much will Jody earn in 4 weeks? Delaney, since you set it up. D is correct, 720, because you put 60 times that, that's 180 times 4. 720. Okay, good job on that. All right. Let's go to the next one. This one requires some translation here. Donna, you want to read this one, number 4.
Lauren spends $50 a month on entertainment, which is twice as much as Patrick spends, and $30 than Josh spends a month on entertainment. How much do Lawrence, Patrick, and Josh together spend on entertainment?
Okay, so that's a lot of info. Let's go variable by variable, person by person. Okay, what's the first translation you're going to make here?
Lawrence spends $50.
So that is translate.
$50.
Still not it. Okay, Akiko. L equals 50. Okay. As you guys get deeper into algebra, some of you guys are algebra 1 right now. When you get to algebra 2, you're no longer going to think of these just as people. You're starting to think of them as variables. That's what I'm trying to get you to do. Okay, the next part, Jack, what would you do?
P equals P equals L divided by 2.
Okay, you could say L divided by 2, which is equal to
25.
25. Okay, correct.
And
If you want to do the third one, Josh.
and Josh equals L plus 30.
L plus 30.
And that's 80.
Correct. Okay, so you got all 3 values there. So this is why, before we continue, this is why it's important to translate. There's so much information in here. You want to take it part by part. Identify the value of each person. The reason why this guy Josh turns out to be 80 is it says that Lawrence, $50 is less than Josh. It's $30 less than Josh. So that's why. Okay, so continue from that one.
So since it asks for how much they all spend together in 2 months, you do LPG times 2 equals the total that they spend in 2 months.
Okay, so you get 2 times.
And I got 310.
Right. So 50, 25. Oops. So this equals 155 times 2. So our final answer is 310. That's correct. Final answer there is 310. So one of the things that people forget is it's 2 months this is asking about instead of just 1. So that's kind of tricky for some of us there. Okay. Questions on this? Does everyone see how much translation is going on? Okay. Let's go to the next page. We're going to talk about translating from English into math. Let's start with Victor with number 1 here. Can you read that for us? What would you do with this one, Victor? Not sure. Cindy, help out. Yeah. That's correct. And what I would say is this, the easiest thing to start with when translating a sentence like this is the word is. Does anybody know why is the easiest thing to start with? Jack?
It means it definitely is, or like it.
It is what it is. Yo, you know what I'm feeling it? You know, it is what it is. No, okay. The reason why is the word is means equals. So that means that everything that was stated before the word is on the left side of the equation, okay? Everything that follows the word is on the right side of the equation, okay? So the word is probably where you want to start. How about the next one here? Let's go to Matthew. What would you do with this one?
I did 0.5 power equals S.
Let's write this out and let's go left to right on this, okay? Let's start with this. How do we translate R? Give me an R. Oh man, you guys are horrible. You don't have cheerleaders on your team. Give me an R.
Yes.
Wait, you guys did not give me an R. Give me an R.
Give me a K.
What? Give me an R.
Give me a Z.
You guys are supposed to say R. Let's do this again. When you get to high school, you go to football games, you go to basketball games, and if the cheerleaders say, give me an S, you guys are going to go S. If you go, give me an I, you'll say I. Okay, so give me an R.
B.
R. Okay, so you go R. Okay. What is? Equals. Man, I can't believe I said give me an R 5 times. And then I got R. Okay, that was horrible. Okay. Okay. So I would hate to be a cheerleader. I would be so disappointed. But anyways, what is half? 0.5. Okay.
Over 2.
Wait, what is of? Correct. Sydney said it. times.
Mia.
Who said it?
Mia.
Oh, Mia said. I didn't see it. I just heard it. So it's Mia. And then what is S? S. Thank you. Delaney will understand. Okay, there. Give me an S. S. All right. So, anyways, R equals 0.5 of S. What Matthew said earlier was a little different. He said R times 0.5, which is not the same. What I want to emphasize right now is that this translated easily from left to right. Look at this. I mean, if I drew arrows, each word, don't make noise. I'm serious. Okay? So R is R. Is equals. Half is 0.5. Of is times. S is S. Do you guys see that? Left to right. It should be that easy. Okay? Let's go to the next one here. Let's go to number 3. Zoe.
X is twice as big as Y. X equals to Y.
Okay. So X equals to Y. That's right. So this is X equals, so is twice as great as. Okay. Let's go to the next one. Let's have Delaney, number 4.
2 less than M.
Okay. So how would you translate that?
2 minus M equals 1.
Less than M. Okay. So it's a little bit different. 2 less than. Victor? M minus 2. This is tricky. And then what's the rest of it, Victor? Equals N, right? That's correct. So this is one of those tricky things. We talked about this earlier. Less versus less than. So this is M minus 2. Okay? Questions on that one? Everyone's good on it? Let's go to number 5, Akiko.
The product of A and B is doing more than their sum. So A and A, B
Okay, AB.
equals AB plus
Is it AB plus 3? What is their sum?
AB times
AB? Wait, no, it's still not AB. What is it? Victor? Not 3 plus, that's what she said. You got it, Akiko? Okay, what is it?
it's A plus B plus
Yes, A plus B plus 3.
Sorry,
Because it said the sum, their sum, which means the sum of A and B, right? So that's what they're dealing with there. Okay. Questions on that? That was a little bit trickier than the other ones. Okay. Let's go to the next set here below. We're doing pretty well here on translation. Let's go to number 6. Jason, you want to read that for us?
Divide the sum of 6.
Okay. So what would you do here?
All of this. 6 over 9. And 2 and 7.
Is it 2 and 7 or 7? It's 7 and 2. Let's double check that, Jason. You said 6 over 9? I wouldn't say that. What is the sum of 6 and 9, Jack?
15.
It is equal to 15. This is 6 plus 9. So this is 15, right? And then what is the positive difference of 2 and 7?
7.
It should be 7 and 2. Why did I write 2 and 7? It should be 7 and 2. Okay, 7 and 2. But what is the positive difference of 7 and 2? So
Wait,
what?
how do I say it?
No, I'll call on you if you do. Mia? The answer is 5 there, okay? Okay, so 15 divided by 5 is 3, okay? So that would be our answer. Let me emphasize something here. How many of you guys have heard the phrase positive difference? What is positive difference, Jack?
So you would always do the number with the higher absolute value minus the number with the lower absolute value. So if you did it the other way around, it would be negative.
Right. Actually, you would take the absolute value of the whole thing regardless. So even if it was 2 minus 7 or 7 minus 2, you would take the absolute value. That's correct. So positive difference means take the absolute value of it. So regardless of what order the numbers are, low to high, high to low, then just take, after you're done subtracting it, take the absolute value. You don't take it before, you take it after. Okay? You guys get it? Okay, good. Let's do another one here. Let's go to number 7. Let's go with Sydney. You want to read that?
Multiply with positive difference of 9 and 7
Positive difference of 9 and 7. Okay. What would you do with that one? So you're doing the absolute value of 9 minus 7, okay, times the sum of 3 plus 4. What is that going to be? Yeah, so this is 2 times 7, 14. Correct. Good. So you guys are seeing that now? Okay. Mia, you want to do the next one? Number 8. Okay. Okay. She's multiplying 5 and 8. And she's adding 3. Yeah, because you're adding afterwards. We're following the rules of PEMDAS here. So our final answer here is, Mia, did you get it? Final answer? 43. Okay, good. Excellent. Let's move on from this. I'll leave 9 and 10 for you guys to do, but I want to cover a few more things in our lesson. Maybe if those, I think you guys are getting it. It's a little bit redundant, but I want to cover a few things. Maybe we will have time for a practice quiz. That'd be awesome. So let's go to this other one. Let's go to number 11 here. Catherine, you want to read 11 for us?
Rob has 22 stamps, and Sarah has 41 stamps being wrong. Sarah gives 15 stamps to Rob. How many stamps does Sarah have left?
Okay, so how did you translate this first?
So R equals 22.
Okay, R equals 22.
And then
How do we translate Sarah? Whenever you have people, you want to translate them.
R plus 40.
R plus 40. So Sarah is equal to R plus 40. And we could actually find a value for that. What would it be? For Sarah? Cindy, did you have? 62. Okay. Now what do we do with this information? We found the information. What are we solving for here? So Sarah gives 15 stamps away. So this is like saying S minus 15. So we know this is 62 minus 15, which leaves Sarah how many? Cindy, do you know? 47. Okay, it's 47. That's correct. Okay, so answer C is 47. All right. Let's continue to number 12 here. Cindy, you want to read this one for us?
And its price increased $4 on Monday, increased to $6 on Tuesday, and increased $2 on Wednesday. What is the final price in stock on Wednesday?
Okay, how would you do this one? Monday is 25 in the beginning. What happens? Okay, by how much? Okay, so that goes down $4. And then what's their final price? Look how I set this up. It'll be a lot easier. Starting and ending prices. But go ahead. So you're subtracting 4, you get 21. So what's the starting price on Tuesday? Starting price is 21, and it adds $6. 27. So what's the starting price on Wednesday? 27. There you go. I set it up like that because in the real world, when you look at stock markets, there's a starting price and there's an ending price. And it usually goes up or it goes down. Okay? So that's why I set it up like that. Let's go to number 13 here. Donna, you want to walk us through this one?
Diane painted 1/3 of the room with 2.5 cans. How many more cans of people should we?
Okay?
I don't know how to write it like as an equation, but I don't know how to get it.
You were just feeling it?
Yeah.
It was just like, you know, it was just feeling it, right? Okay. Can someone help us out with setting this up? Because I don't want to just go by that. Okay? Jack, what would you do?
1/3 equals 2.5, or you could do, well, 1/3 is 2.5, so to get the total, you would do 2.5 times 3.
Yeah, the reason why you would get that is because 1/3 plus 2/3 equals 3/3.
You just do 2.5 over 3.
2.5 over 3, I wouldn't do that. But this is better with what you're doing here. This gives us what number here? 3 times 2.5 gives us
7.5.
7.5. Is that our answer? It's actually not the answer.
Oh, cans.
Because the answer is saying how many more cans does this person need? She only needs 5 more. She used 2.5. So this is the total minus the used, which is 2.5. So it's 5 more. So she needs 5 more cans, okay? You could have done it faster just by saying 2.5 times 2, because she has 2/3 left. This is where you get the 2 from. 2.5 times 2 equals 5. So that's how you get 5 cans there, okay? So that's how I would do that one. Questions on that? Akiko, your face is, your eyebrows are like kind of like wrinkled there for a second. Do you get why it's 2.5 times 2? Because 2/3? Otherwise, you could just say 2.5 times 3, which is 3/3. That gives you the total. To paint the entire room, she needs 7.5, but you're subtracting what she used already. So that's 5 more, okay? Cool? All right, good job on that one. Let's move forward. I want to introduce the concept of back solving. And back solving is using answer choices to go through a process of elimination so that you don't have to reconstruct the equation from the top, but just go through the answer choices. Okay, let's go to number 14 here. Let's have Victor read this one.
There are twice as many men as women on the track team. Medals were given to 1/3 of the women. There are a total of 45 men and women on the team. How many women received the medal?
Okay, so there's a lot of information here. What can we start with on this one to translate? Because there's so much stuff here. Zoe, is that a hand up? Go ahead. I thought that was a hand up. You're even shaking your key, making noise though. Do you want to help out or not too sure? Okay. Jack?
You do 45 divided by 3 because they say there are twice as many men as women.
Slow it down. Okay, so 45 represents what?
The total of men and women.
So this is equal to men plus women. Okay, now Jack said, let's divide it by 3 because we know there are twice as many men as women. So that means men equals 2 times W. Okay, that means men is double the amount of women. Okay, so now he said, let's divide 45 by 3. When you divided 45 by 3, what do you get?
50.
So that 15 means that if you had men versus women, this would be 15 women and 30 men. Because if you put in the 15 in here, you'll get 2 times 15 equals 30 for the men. You guys see that?
And then if you divide the women by 3, because 1/3 of them got medals, then it is 5.
Right, so women divided by 3 equals medals, okay? And that means 15 divided by 3. So that's 15 divided by 3 equals 5. There's a lot of translating going on in this equation here. So it takes a few steps to get to the answer. Some of us might have gone to the answer choices and gone the other way around and said, well, if 1/3 of the women got medals, we could test them out. This might have taken a lot longer because you'd be like 5 times 3 is 15. Is that 1/3 of 45? That takes a little bit more effort. But if you do back solving, what's going to happen is you'll start in the middle just to see if it's too big or too small. And then you can eliminate likewise. But I think for this one, it was easier to translate. Okay? Let's continue to the next page here. Let's do another one. Let's go to 15. And this is an interesting question here. Jason, you want to read this one for us?
Probably students are in a smaller group.
How would we, first of all, how would we translate this one? Okay. I had a friend who was a math teacher at like one of the middle schools around here, and he's really into rap, and I think he can rap his math lessons, although I'm not sure if everyone really wants that. But let's see. What would we do first here? If we translated this, what's the first thing you guys notice? I'm sorry, say that again? A class of 30 divided, well, should you divide it by 2, first of all? Should you, because one is a larger group, one is a smaller. So no matter what, larger is greater than smaller, right? Because that's the whole concept of larger versus smaller. Does everyone agree? But if you look at that, larger plus smaller equals 30 here. Now what Jason said was divide by 2. Well, you know what that tells you? 30 divided by 2 is 15 and 15. We know that 15 could not be the answer. Why? Why is 15 not the answer? Jeff?
Because 15 divided by, or like 15 can't be 2/3 of half. Or I don't know how to put it into words, but it's not the answer.
I'll tell you why. So what I wrote up here on the board was 15 cannot be the answer because large does not equal small. Large does not equal small. No matter what, large has to be greater than small. So this question is asking you, how many students are in the smaller group? The smaller group has to be smaller than 15, Matthew, correct. Has to be smaller than 15. Because if it's 15, it's equal to larger. So the smaller group has to be less than 15. Do you guys agree with me? So are there answer choices we can knock out here? Are there answer choices we can knock out? What can we knock out, Matthew? 16, 18, and 20 are out, just like that. This is back solving right away. These are not allowed as numbers, okay? When we look at this, the relationship between smaller to larger is the following. Smaller is 2/3 the size of large. Let me just write it this way. S is 2/3 of larger, okay? So if that's the case, we should test out A and B. If we put in 10, is it going to give us 20? Because when you're looking at smaller, if it's 10, this is 20. Let's test it out. 10 is equal to 2/3 of L. Is L going to equal 20 here if we do this? If we clear this denominator, you have 30 divided by 2. This is equal to 15. So that's not correct. right? You guys see how I did that? This is 3 on both sides, 2 on both sides. That's where I got 30 divided by 2 is 15. You guys see that? So this is not correct because it gave us L as 15. We need L to be 20. If S is equal to 10, then L has to be 20, okay? So let's test the other one out here. If S is equal to 12, then this has to be 18. So let's put these into this formula. S is equal to 2/3 of L. If we put it in here, this is 12, 2/3 times 18. Is this true? 18 times 2 is how much, Sydney? 36 divided by 3? It's 12. So this verifies itself. 12 and 18 fit. 12 and 18 add up to 30. You guys see that? So our answer for the smaller group is that it's 12. Do you guys see how that works? Okay, good. That was probably a little bit harder than most other questions here. Okay. Let's go to number 16 here. Catherine, you want to read this one?
A painter charges $12 an hour while his son charges $6 an hour. If the father and his son work the same amount of time together on the job, how many hours did each of them work if their combined charge for their labor was $108? Since the father and son work the same amount of time together, would you add?
You could.
12?
You could. So this is the painter plus son, 12 plus 6.
So it would be 18 an hour.
18. What do you mean by L?
No, 18 an hour.
$18 per hour. Okay. Okay.
And then it says how many hours each of them work if their combined charge was 108. So you do 108 divided by 18.
Wait. So 100. This is the equation here. What Catherine is saying, I'm writing it into an equation because she said $18 per hour. The question is asking, multiply this by how many hours to equal $108. Okay. Same number of hours. Okay. So if that's the case, she's dividing 108 divided by 18. That's going to tell us how many hours they work. Okay. What did you get? It's 6. So if they work 6 hours, they generate 108 together. Jason, was that a question or comment? Okay, it's 6 hours here. So 6 times 18 is 108. Let's go to 17 here. Let's have Victor read this one. Okay. So how do you set this one up? Subtract which parts? 875 from, or 88 from which one? Just read it to me like an equation. Right, so Victor said 875 minus 88. This is the total sale. This is the profit. This is the buy price. Okay, what did you get on this one? 787, thank you, Victor. So this is 787.
787.
That would be how much this person bought it for. Okay, and that's how much he paid originally for this. You guys are doing really well today. We're going to go back and do a quiz because you guys are so awesome. So let's go back a few pages here. I know if we don't get done with both of the quizzes, you'll do one of them for homework. So let's do the one on page 27 and 28. for the next couple minutes and we'll review them, okay? All right, let's talk about the answers. By the way, if you don't get to the second quiz, it's on page 36, so you can just add that to the homework, 36 to 41. Number 13, the answer here should have been C. That does not equal 12 because you multiply 1 times 2, that's obviously 2 plus 5, that's 7. Number 14, this should be 0. The negatives cancel out the positives here. Number 15, this answer should be 4 below 0 or just -4. Number 16 is 32. The answer is E, because the factors of 21, when you add them up, are 1 plus 21 plus 3 plus 7. So that's 32. Number 17, the answer is 36 cents, because 36 cannot divide into 96. 18 is D, and that is a number that is not divisible by 30. If you look at all the other numbers, they're divisible by 30. Number 19, the answer is C, 48. They're both divisible both by 6 and 8. Number 20, the answer is 30, which is C. How many guys got 100% on that one? Okay, how many of you guys have questions on some of these that I read to you? Delaney? 19 was 48, because it's a multiple of both 6 and 8. Usually people ask about number 20, but for that one, you're adding up the numbers plus 24 plus 30 equals 72. That's how you get that. Okay. We're going to probably wrap it up right there because it's right at about time. The homework goes from 36 to 41. If you haven't turned in your other homework, you can turn that in. But other than that, it's a wrap for today. Okay.